One of the primary tools that astronomers use to think about the abundance of life in the universe is the famous Drake equation, first written down by Frank Drake. It is essentially the number of stars in the galaxy multiplied by a long list of possible factors, such as how often do you have planets, how often are those planets Earth-like, how often does life begin on those planets, and so on and so on. Now, when we look at this, it's like a narrowing filter, and you can imagine with the rare Earth hypothesis by Ward and Brownlee adding on extra terms, such as having how often does the planet have a large moon? How often does it have the same mass as the Earth? How often does it have the same land mass fraction the Earth has, or the same ocean salinity or chemistry, etc., etc. And you can imagine adding on hundreds, even thousands of extra parameters onto the Drake equation, which get ever narrower. And of course, if you multiply a very large number of fractions together, you'll eventually get zero. Now, on each one of those criteria, you can make a good case as to why life on Earth indeed requires those conditions. However, we really don't know whether life elsewhere does or does not require the same conditions that we enjoy here on the Earth. So for example, there's some thermophiles that can range from minus 25 degrees Celsius, and then you have other extremophiles which can live at 125 degrees Celsius. But the fact that extremophiles today can survive in such an extreme range of temperatures doesn't mean that life could begin under such an extreme range of temperatures. Maybe the nascent conditions for the birth pangs of life to begin with, the abiogenesis event, the spark of life which created all life on the Earth, maybe that requires very special and subtle temperature range that cannot be violated. These are questions we just don't know. What were the initial conditions on the Earth that led to the emergence of life? And if you just go another step further, even defining life is an incredibly difficult task, and there is definitely no consensus about how to call such a thing. Maybe it's actually better to call it more like porn, like you will know it when you see it, rather than having a strict textbook definition of it. NASA have certainly tried to have a definition. For a long time, we had a definition from NASA that said it is a self-replicating chemical system capable of Darwinian evolution. And that's pretty good, but maybe chemistry isn't actually necessary. Maybe you could have an AI system or self-replicating technology that would still resemble life in many ways, but wouldn't actually involve the kind of chemical systems that we're familiar with.